Okay, we want to stay on schedule here, so we're going to get started again. We are very lucky to have an outstanding wheat breeder at MSU. We were asked along with our industry partners to help support the wheat breeder position. It has been a great investment for us and for the state's wheat farmers to have a bright, young wheat breeder ready to make a difference in the industry. It is my pleasure to introduce Dr. Eric Olson, newly tenured MSU wheat breeder, to share with you the varieties he has on the horizon.
Okay, here we go. It's a little better. So it's good to see everyone here. So as I was saying, the best thing about Michigan is the whole value chain of wheat. And so if you're here today, you're probably growing some wheat, and you probably want that crop to be profitable. And so that's part of why I'm here. Is the mission for our program is to increase profitability. And we do that through genetics. And so within our program, we develop wheat varieties. So we're introducing new genetics and new improved traits, and we're pushing the ceiling on traits like yield and incorporating other important traits like scab resistance. So it's been about 10 years, and there has been a wheat breeding program at Michigan State for about 80 years now. I have memorabilia at MSU from folks, Dr. Grafius back in the 1960s and Dr. Everson back in the 70s and 80s. And then there was Rick Ward and Janet Lewis. And all of that, the successes from those programs, we are building on currently. In terms of quality, there's a whole value chain in wheat, right? All the way from production, from growers, all the way to consumers that are buying those frosted mini wheats, buying those crackers. Everything in the middle of the supermarket. There's a lot of wheat out there. So there's a lot of value across there in the milling industry, strong milling industry presence in Michigan. So we have really good quality available to us, and we're really pushing traits like yield, and you can have all of those traits in a single variety now. And so I want to talk about some of the folks that we work with. Dennis Pennington has been a great collaborator, and we've been able to work together to do the kind of research that matters to folks here in this room. And we have some great staff and graduate students as well. I'm going to kick off, so I'll talk about the structure a little bit. I'll talk about some of the traits that are important in the program. And these traits that are important in the variety development process are also important in production. So when we talk about disease resistance, you probably don't want to hear about it, right? That is something that we don't want in those fields, right? And the way that we can keep these pathogens, especially Fusarium head blight, that's, in terms of the traits that we work on, that's number 2. Grain yield's always going to be number 1 because that's what we get paid on, right? But then the second thing, well, you don't get a bonus for quality. Yeah, like with protein, for example. The hard wheat folks can get a premium on their protein, right? If they're lucky. If they're not lucky, you're spending extra money on that. But we're trying to preserve what we have with these disease resistance traits. It's defense, right? We're going on offense when we're looking at agronomy practices, and we're going on defense when we're looking at diseases and so forth. And so you may not think about leaf rust at all because it doesn't arrive very late, but if this disease, leaf rust, arrives early, let's say 3 weeks earlier, it comes in at the late part of the season, right? We're already at probably a hard dose stage by the time you see it. But if it arrives 3 weeks earlier than that, look at that flag leaf. I would say 75% of the current commercial varieties would look like this if leaf rust started any earlier during the year. And at our Mason breeding nursery, we had leaf rust overwintering. We had fall infection. It's out there, okay? It's not right in our faces every single year until it is. Did anyone grow wheat in 2016 in this room? Probably more than, but anybody remember stripe rust? Anybody have stripe rust in their field? We weren't thinking about it. It hadn't shown up for quite a while. It hasn't shown up since then, but from that experience, we know which varieties are resistant, but we also know that we need to be phenotyping it and have this in the background. So every variety with a disease resistance trait, it's an insurance policy. Every one of them comes with a built-in insurance policy against high DON levels or yield loss, right? So they're defensive traits, good defense, right? So Fusarium, we keep working on that. I'm going to do a deep dive into how we're working on Fusarium and these other traits as well, and extend that into some of the things that make the MSU winter wheat breeding program unique relative to other commercial entities, and other universities, right? So 60% of the wheat varieties in the United States are developed in publicly supported, i.e. wheat growers and Congress are supporting wheat variety development at universities that are then entering the marketplace and then production, right? So about 60%. And that's because we don't have hybrid wheat yet. It's on the horizon, but I would see more commercial investment then. And one of the investments from this community is in how we can develop, how can we go faster, and how can we be more efficient, right? And so these disease-susceptible leaves, this is leaf rust in the greenhouse. I mentioned the great staff that we have, and they're now experts at growing hundreds of thousands, about 180,000 plants at a time in the greenhouse. But we're able to cull from that group, cull them out to where when we go to the field, there's a 90% chance when we advance those lines into replicated yield testing, they're going to be resistant. So we're going to get the traits. We're trying to get the traits that we want before we start investing in these varieties down the road. And so you see these at high density. We can go from making a cross to having a line that can be increased and then tested in 2 years. So the old school timeline, you want to add foundation seed and certified seed production, it's almost 14 years, 12 years if you're really, really aggressive about it, using some previous methods with some investments in our greenhouse facility and establishment of this mini bulk protocol. I call it a poor man's double haploid. For pennies, we can develop these inbred lines that would commercially cost around $55 a line. We're producing them for about 6 pennies per line. So real efficiency in terms of screening and cost. Because if we can get more volume, more lines, it's a numbers game, just like farming, right? We have margins. If we want to find a better variety, we have to screen more material. So if we can do it with a lower cost, we're getting ahead. So we can eliminate all of these susceptible varieties, these genotypes, before they even go into the field, into replicated testing. So what we're seeing, this was work done by a graduate student. This was Melissa Winchester. She's now working in the floriculture industry in Western Michigan, a research director for a floriculture company. But she had a lot of time in the greenhouse screening disease on these plants. And so we can identify these types in the field before they even go to the field. So we don't have to screen them in the field. We know we're going to get this resistance trait. And we can see in silver here, every population that underwent selection where we remove those susceptibles had a lower disease score. So with disease scores, lower is better, right? Yield, more is better. Lower disease scores for fusarium-related traits are better, way better. And so what we're looking for in this nursery is resistance to fusarium. And you can, kind of what that looks like visually, you can see in these different spikes from the greenhouse. So this is from Mel's work. You can see this highly susceptible line. That gray area there, that's dead tissue. That's where the fungus got in through the flower at flowering and infected that entire spike. And in its wake, it's producing mycotoxin. It's producing DON, right? That's what we're concerned about. That's the trait. And so indirectly, less fungus means less DON, right? More resistance means less fungus, which means less DON. And so you can see we have varieties that are similar to this here. The fungus was able to get in through one. Think about this as an intruder. That's your house. That's your wheat spike. It got in. It didn't get past the foyer. It got in through the front door. It saw that Rottweiler of a resistance gene that is fighting back, and it kept it right there. It didn't break into the rest of the house. So those disease resistance traits are important, and you can see that on a larger scale. What we've got here is across this nursery. It's about 4,000 individual plots. There's about 700 different varieties. So we're taking. This is part of our connection to every other breeding program and every commercial entity that's developing and releasing wheat varieties. Is through the U.S. Wheat and Barley Scab Initiative, the screening program here. Every variety that's marketed in Michigan has been through this nursery and has been challenged to a very high degree with fusarium. And so if you see something that has comparably lower DON and comparably lower disease, these other traits. I'll get to those in a second. But if you see something that's resistant, it's been through many successive steps of screening for this disease. And if you're growing it in Michigan, we've evaluated. That means that the seed companies have this information and can communicate that to you. And we also communicate that through the wheat variety testing program. So that's another part of what we do is commercial wheat testing. And so even though we collaborate extensively with other seed companies in the region to bring those genetics into Michigan. So we may not be promoting and testing genetics from within our program, but we're getting those genetics from other places. KWS Cereals, Grow Pro Genetics, that was formerly Syngenta. Even Corteva is represented through other means here. So we're really working across the board with those that are developing wheat genetics for Michigan to ensure that we have this high level of resistance that we need in this material. And so a little bit about the disease. Of course, it gets in through the flower there. It's a flowering disease. Just kind of, it's similar to sclerotinia. If you dry bean folks, soybean folks, it's going to get in through the flower. And then it's going to move within that spike and infect the actual grain itself. And we know that there's a weather component, right? There's a weather component where these high humidity, high rainfall events are going to promote the production of those spores. I'll talk a little bit about this. Fusarium is out there. It's in all of the Johnson grass, all the warm season grasses out there. It's ubiquitous. So it's not a question of is fusarium going to be a problem or is it present? It's always present, and it just when that environment variable gets introduced, rainfall, high humidity, warm temperatures at flowering, that's going to trigger the presence of this disease. That's why we need to have the resistance in the background of every variety that's out there. It prevents a large-scale event. I don't know, some folks might have been farming in 1996. If that year rings a bell, you can see it on the yield charts from across all the eastern U.S., across the U.S., and even in Ontario. There's a huge drop in the averages across North America, and that was a result of fusarium. And so 25 years of the U.S. Wheat and Barley Scab Initiative that's been in every single farm bill since then, and hopefully it's going to be in there in 2023. That's another thing that we do in the wheat community is advocate for research that benefits growers. In coordination with this is part of our connection to the national office, National Association of Wheat Growers. I'm on a bit of a tangent here, but there's the National Wheat Improvement Committee, and I chaired that group. I had the opportunity to advocate in Washington with Dave Milligan several times and this is one of our asks. There's plenty of other asks through the national office, but that's how we were able to make long-term progress on traits that matter to growers is through this kind of support. And so you can see we end up 25 years later with the capacity to develop lines that have just a few little pockmarks of fusarium infection in contrast to this. This would never make it. This would never make it out the door from our program anyway. And we'll see some of that data later on in the program. I'll talk about some of the actual varieties that are pretty close to being to the point where we can release them and have them enter the production of foundation and certified seed. So I talked about Don a lot. So severity, what we see here is the difference. This is a difference in severity. How far does that pathogen move within the spike? Then we can look at incidence, is how many individual infections, how many heads. You could be looking at 200 heads, and your estimation of how many of those heads are infected. That's incidence. And that from those you can create an index, basically a percentage of how many total spikes or how many individual spikelets are infected in that individual plot. And, of course, we want that number to be very low. And it's correlated to Don. But remarkably, Don is not perfectly correlated with these other traits. So we also have to do a chemical analysis, which is very expensive and resource intensive. It involves milling about 1,000 individual grain samples and shipping those off to a facility at the University of Minnesota where they can provide us very specific data, very, very high quality data on the Don levels that we then use for the future. So all of Michigan is represented in this nursery. At least one, we have 6 different isolates from different variety trial sites. Now, we don't see epidemics of fusarium head blight every single year, but we do see traces of it to such a degree that we can go into our the grain that we bring back from our replicated trials. So we have trials, we have one on the site here, then in Huron County, and then in Sanilac County near Deckerville. So we have an isolate here from last year from Huron County. We didn't hear much because of the drought, largely. There were drought-affected areas. those aren't fusarium-producing conditions, but it's still present at such a degree that if we look through 10,000 seeds, we're going to find one of them that was infected. And then we grow those up in Petri dishes, and we infect corn. So we find that corn is a very good agent for transferring that disease to the field. So it hops from corn to wheat. And so that's why there's the recommendation for wheat to follow soybeans. Fusarium is responsible for part of that recommendation because it's in the corn residue. It's in those harvest loss kernels that are still in the field. And they will end up looking like this eventually. So we culture them on corn on purpose because it's a good vector to get it out in the field. And then what we see, we see slight differences in these. And I can connect that to some work. So a lot of what we do is connected to ongoing work with extension faculty. And Mary Chilvers is a fusarium expert. And so we can categorize these as having unique properties in terms of how aggressively they infect wheat, how quickly, and can they do this at lower temperatures too, and also what type of DON, which specific DON molecule, and how much of it, right? So they vary. You can see this one's a little bit lighter in color, and that's some fluffy mycelia on the surface, but this one's a little bit redder, a little bit meaner looking. That's DON. It's producing a bit more of that pigment. What you see is that the pigment, the actual color of the DON showing through. And so, we've got Mason identified here, and it can change what we get year to year. That's why we're testing last year's isolates the next year to sample all the potential threats in Michigan. And we actually inoculate them. So within these rows here, we will then spread this grain spawn. We call it grain spawn. And so at different times, and I'll get to this a little bit later and connect this to the value of planting multiple varieties on your farm. Wheat varieties flower at different times. Right? We know flowering is a very critical time for management, right? For applying that fungicide to control scab. And so we have varieties are flowering at different times. That means they're vulnerable to the disease at different times. We need to have that disease present across the whole time frame. And so what this crusty looking thing here, that black surface there, that's spores. I'll be careful with my imagery, but they're like little bombs going off and sending spores throughout that nursery. But you can see this one right here is still kind of white, and it's just starting to turn black a little bit. That means that these are about 3 weeks apart in terms of their development. So we always have good disease pressure throughout the cycle of infection. And so that's something that we've been very successful. We have had a successful fusarium nursery in drought, in heat, in everything we've thrown at it. The staff has gotten really good at handling all the curveballs. And so I want to connect the genetic resistance that I've been talking about to chemical controls, to fungicides, because both of them together is the most effective control for fusarium head blight. I'll just say that again, just to make sure. The best control for fusarium head blight is resistant genetics with a fungicide applied at the right time and at the right rate. And at this point, after decades of research, we're at a good place where we can have both of those together to get very good control. And this. I just want to make a point about avoiding the vulnerable varieties, the susceptible varieties. The best, if you're going to make one move to control scab in your program, in your fields, it's to avoid a susceptible variety. The best move that you can do is to not select a susceptible variety. If fusarium is your number one concern. Because even a moderately susceptible variety means it's not totally susceptible. It can hold its own a little bit. Even that, or moderately resistant, right? That genetic resistance. The genetic resistance is better than spraying the susceptible with a fungicide, right? I'm not going to name any names for some varieties. You maybe know who they are. But if you're growing, it's better to just plant a resistant variety and not spray it than it is to plant the susceptible variety and then pay the $20 per acre for product to protect it. The better move would be to buy the certified seed of the moderately resistant variety. Even better, buy the certified seed of the moderately resistant variety and make the investment in the fungicide, because that is going to give you the best possible control relative to the unsprayed susceptible check. That's what this is in reference to, just having a susceptible, 1996, right, all over again, right? This is, in comparison, we're 70% better with a moderately resistant variety sprayed with a fungicide. And a susceptible variety, a fungicide cannot make up the difference between that. A fungicide cannot make up for genetic vulnerability to scab. It just can't do it. There's a 30% difference there, and the fungicide cannot bring the susceptible all the way up to the same level as the moderately resistant. So it's an important consideration. The best possible way to control scab, moderately resistant variety, sprayed with a fungicide. So to get better, so it's important. Selection is important, and we're always looking to try to screen more material more accurately for fusarium, so that we're always testing material. Later in the program, a yield plot costs anywhere from $25 to $55 a plot, depending on how many times you drive over it, right? And so we want to make sure that anything that we're investing in the program has this resistance already. And so making selections is important. So this is a project. We're going to go a little bit basic in the research. So we're always working in the background on ideas and projects that can then be translated to the field. And one of these, and this is at work in the nursery, the disease nursery, but it started in the greenhouse. So we're looking at thermal imaging. So we're getting into some cool phenomics. How can we're flying drones, we're collecting hyperspectral imaging on our yield plots, but in terms of working on scab, we're using thermal imaging, and I'll talk about some hyperspectral imaging as predictive tools to identify those resistant individuals. And so you can see, I am going to name a name, Ambassador. DF Seeds has it out there. It's got really nice big kernels, but be careful because it will do this. It is very susceptible to fusarium, so it has to have a fungicide. Now here's a line that it's commercially, it never made it, but it has the best fusarium resistance of any variety. It's a soft white winter wheat with the FHB1 gene. Is the most resistant line that we see. We use it it's our resistant check. It has good yield potential, and the quality has some strange protein properties. But the point is, you can see this very high level of resistance. So where it was inoculated with the fungus, it didn't move. It has that really high level of resistance. And so what we're doing this was imaging in the greenhouse then, and we found in the greenhouse this association at 20 days after inoculation. So you can see, here's our Ambassador. If it's inoculated, it's about 3 to 4 degrees warmer than the resistant individual. So we can differentiate resistant lines that are resistant to fusarium versus susceptible based on temperature, that small difference of 4 degrees Celsius, imaging the whole spike, because that dead tissue, it's not moving water anymore. You know, plants cool themselves off they're pulling water through the ground up through the leaves. It's just if you run a greenhouse facility, that's evaporative cooling, right? So plants are cooling themselves by essentially breathing water. They're moving water through their system. So these susceptible spikes in the field, and you can see it shows up in the field as well. It translates from the greenhouse to the field. These susceptible spikes are warmer because they're not cooling themselves off. And so you can then resolve these these sometimes subtle, but not too subtle, temperature differences, and then differentiate your resistant to susceptible varieties. And so I wanted to share an image of, this is John, a graduate student, collecting some data in the field here. So we've got some thermal imaging, and here's the FHB resistance he's looking for. So it's a reference. It's a 1987 Predator movie. It's thermal. So anyway, I thought it was pretty funny. Anyway, so that's visual. That we see that in the field. We inoculate and then we observe and we collect that data. We still walk the plots too. We would love to get to a point where we could just have a mobile device, some kind of a small tractor, move through the field and collect these images and then feed them back, and automate the scoring process. We can do that to some degree with hyperspectral imaging. We're able to image grains. So, the whole process for evaluating mycotoxin, you have to get the disease in the first place and spend months getting that disease. Then you have to harvest every single one of those rows, thresh it out, grind the samples, and ship them out. It's a long process. It's expensive. And so if we can just image, the goal here is to just image the grain. image the grain at 400 different wavebands. So anyone who's doing work with NDVI or nitrogen, predicting when you need nitrogen and how much nitrogen you need, you'll be familiar with the near-infrared range, right? The NDVI range, it's built on a couple of those wavebands, some of which are represented in what we used here actually for evaluating. But that's kind of a high-level overview. But what you can actually see then is differentiation. We can predict with statistical models, we can feed these statistical models the data from hyperspectral imaging. So we're imaging just petri dishes of infected grain. Here's our W190 check here, the resistant line, and you can see this very dark pink pigmentation here in the ambassador. That's the Don showing up, right? And there's some of the most significant wavelengths are associated with pigment. But the takeaway is that we can get 80% accuracy in prediction for Don just by taking images. We don't have to grind all these samples and run them through expensive equipment in a lab somewhere else. We can, in our own program, predict just on a grain sample what that Don level is going to be, right? We're not quite to the point yet where we could, develop a device, that has the sensors to provide that kind of data, but that's maybe 5 to 7 years down the road if we do go that direction. So, but we can use it in breeding for selection. And another tool that we use is genomic selection. And this is big in the cattle industry, heifer replacement for herds or for selecting the specific sires for their herds and so forth based on traits that you have to, slaughter like carcass traits, marbling, etc. It's easier to just take an ear sample from a cow's ear and then look at the DNA. 23andMe, the same kind of technology that's used with 23andMe and Ancestry.com, they're using that to then predict traits like in animals, carcass traits, but also feed efficiency, butterfat yield, all of these different traits that are important in animal production. You can develop prediction models for those and then make investments in more high-value animals, right? We're making more investments in high-value genetics in the same manner for Don. We have very good prediction accuracy for Don, so I can sample DNA from the field from a plant, knowing nothing about that, just what it looks like, what day did it flower. I can then predict what the grain yield is going to be in 5 different locations in Michigan. I can predict with very high accuracy the level of mycotoxin that'll produce under infection, and as well as all these. I can predict how big of a cookie it can make, right? Is it going to make an acceptable cookie? So it's remarkable what genomic selection can do. This is predictive breeding. It's remarkable now. And so we've seen a major reduction. We're culling the most susceptible individuals, and when looking at and advancing those lines that have really low Don here. And you might look at 20 ppm and say, that's not low Don. Ambassador goes up to 120. That's high Don in our nursery, and so it's scaled a little bit. We always get really high disease. I'm going to pause there actually, because I've been going at this for a little while. Does anyone have any comments or questions on what we've covered up to this point? I just want to take a little break and see if anybody's got any questions.
Well, this wheat is flowering at all different times throughout the growing season.
Yes.
When are we supposed to really know when we're supposed to apply that fungicide?
Yes, that is. I'm very glad that you asked that question because wheat varieties will flower at different times. And so I'm going to use Jupiter and Ambassador as a case study here. Jupiter and Ambassador, but Whitetail. Whitetail is a good case study too, where Whitetail flowers earlier in the trial. So what you see in terms of flowering date, it's Julian flowering date. How many days past January 1 did that variety flower? So we're usually taking flowering notes on Memorial Day weekend in mid-Michigan, in Lansing. And so, but it scales. And so Jupiter is about 3 days later. And that can scale a little bit more in the field too. But that's a case where if you have one variety, it's good to check. It's very good to check on those, especially if the weather. So I've got my map of Michigan here. It's usually around Memorial Day weekend and around mid-Michigan. And you can add up to a week up into the thumb here on county. It's buffered a little bit later up there. So there's some calendar dates where you know keep that in your truck, circle that date, check your wheat fields, around that time, and you can narrow it down. You have about a 6-day interval for spraying. The first 3 days are important. So it's the best time to spray is right at flowering. When you see those yellow anthers extruding. If your variety is not a good extruder, you kind of have to go out there and pop open some of the glooms and actually see where they're at. If you see yellow anthers, even if you see them a little bit green, get the sprayer ready. If you see yellow anthers, start filling it. That's kind of a good rule of thumb. If you have 2 different varieties, whitetail would be ready 3 days earlier, right, than Jupiter. So if you have 5,000 acres and you have 2,500 acres of whitetail, you're good. But you have enough time to cover those acres and then cover your later maturity acres at a different time, right? Splitting maturities is one of the most effective ways that you can spread your work around wheat, especially around flowering, but it also translates to harvest too, because you can see up to a 7-day difference for whitetail. I've heard this directly from seedsmen who sell the seed but also grow it on their own farm, that you can have a 7-day window where whitetail will be ready earlier. The earlier flower earlier, and they generally flower earlier and then they'll finish earlier too. Right? There's such a thing as a full season variety that will hang on a little bit longer, and Jupiter's like that. So you can split those maturities there, and that's kind of one of the slides at the end. And I give some of the benefits of planting multiple varieties on your farm, and getting the timing right for head scab application. It allows you to do that when you have multiple varieties. So.
What about one variety, one specific variety? Every wheat stalk doesn't flower at the same day, does it?
It does not. What you're talking about is tillering, right? So the point was that even within a field, you can have variation in the field where some that were on a sandy part of the field can flower early, and you have late tillers. And I'm not going to put any varieties on blast. Some of them do that. Some of them kick out later tillers, especially if it was a dry spring and then we get some rain and then, there's some green. Just same phenomenon as in dry beans will happen in wheat, where you get these extra tillers that are risk factors. And so tiller uniformity is something that we select on indirectly in our breeding program. When I get to actually talk about differences in canopy architecture, there are differences in tiller uniformity. It's subtle, though, and it's not something that seed companies characterize to tell you that, this variety's got a lot of late tillers. But that can happen, and so uniform agronomy is the best way to maintain a greater uniformity for tillers. So if you're putting down a starter phosphorus, that helps tiller uniformity. If you have more uniform N application, that helps tiller uniformity. So there's a lot of things. I'm not saying you have to do everything right, right? But it's if you can dial in as many management components, it actually has these indirect benefits on head scab too. Yeah.
What percentage of the yellow things, would you apply that fungicide?
Right. So you want to for the main tillers, the very top. Sometimes you can have a third canopy down there. Some of these varieties have multiple, different levels to it. The first level is going to be the main tillers, and that's going to be the majority of the yield. So if you're seeking to control scab on, 90% of all the heads in the field, those are the ones to focus on, or take if you have the window, i.e. it's not going to rain. You could wait plus 1 day to try to capture a few more, but there's diminishing returns after that, right? And so it's good to try to get the main tillers when that at the top of the canopy, those main tillers are the ones you want to treat, and get as many as you can. There is some residual for products like Miravis. Now, when I'm talking about hit the mains, we're talking about your Carumba Prosaro products, the go-tos, the triazoles. But then I'm not as familiar with the Miravis because I haven't been doing the research, but I've been hearing about it. And so there is some, not all, you can't apply it at the boot and have residual effect, but the Miravis products do have some residual that they would stick and stay on those later tillers. So that is an alternative with a product they're I don't have data myself to support that residual, but there are products where they might. Yeah.
If you have uneven, maturity in the field, do you feel you'd be better off going with two applications of, let's say, Prosaro,
Right.
or one application of Mirabis?
Depends on your contract price, I think. But it comes down to management, right? And it comes down to what it costs too. If that's so, there's always value when you apply a fungicide. There's always value because you keep the flag leaf clean, right? Back in 2016, there was a decision. Okay, we do need to apply for scab. Do we apply a Feeks 9 fungicide to keep that flag leaf, or do we wait? Do we let the flag hold on and wait for that second application? So I think there's room for that, but it's an added cost. Yes, it would be effective, but it would have an added cost. So, but if you still had like $10 wheat, that might be worth it. Good discussion, yes, sir.
You pick on ambassador. The way you talk, it gets sick if you look at it. Why do they keep growing?
Well, it has amazing quality, and the yield potential is there, but it's finicky. It tolerates drought very well. It doesn't tolerate heat. If you look at the yield trials in 2020, Ambassador was less than mediocre, but then last year it thrived in the drought, and it's just a yield monster too, for that matter. It's resilient to spite me sometimes, I think. But we pick out, we identify checks, lines that we try to beat, and that's one of them anyway. So it's my competition. But it still produces grain, and there's an element of reliability to these lines. If you've grown the same line, there's some value in knowing what to expect from a variety if you've grown it for 5 or more years. But there's also a lot of value in exploring other options too, because the only way that you would know another variety worked is if you tried it out, right? If you kind of set that goal for yourself. But these variety you can cover up a lot of weaknesses, and it's good for calendar spring. So if you're putting down a T1, T2, and T3 fungicide, it will respond to it. Part of that is because it's susceptible, right? Responds well the fungicide translates to it's susceptible to some diseases. So, yeah. Okay, so so overall, our breeding program, we're training our prediction models with about 500 individuals, and for Fusarium we have like 800 that we're training these models with. But from commercial companies, there's about 115 entries every year, and the majority are actual. What I'm getting at is that they're one-hit wonders where the companies are just trying them out, and if they work, then they get marketed to a Michigan company and then sold. And so there's a lot of them that companies are just trying out, but there's probably 30 to 40 different commercial varieties that are consistently sold. And so a lot of good places to get seed, MCIA, DF Seeds, your seed farm. I'm not playing favorites, just those are the really big ones that we know about that enter our commercial yield trials in Michigan. Other good places are like KWS Cereals, and Corteva is under different names and so forth. But it can vary at different parts of our breeding program, but there's 30 or 40 or so. And then we work with a lot of our collaborators, different universities, so some of the trials can get pretty big. I'd have to ask Dennis what our numbers are. Total numbers of yield plots is probably over 20. It's over 20,000 this year. I knew it. We eclipsed 20, so 21,500 yield plots this year. Yes, sir. Okay, potentially. So, yes, good call. The question was, with the warm winter that we're having, are we at risk for any epidemics in the production season this year? We have to wait and see. And a lot of that's weather, potentially. Now, where Where that might have differed last year, we got cold enough to kill off the leaf rust that we had at Mason. And so that didn't manifest. I was worried about it because you see it in walking plots in the fall, but it never manifested in the spring. And so it's hard to predict that. So maybe it's not a really good answer, but I think that there is a risk of overwintering. Now, the stripe rust epidemic of 2016, there's evidence that it did overwinter in a northern location. We don't know that it was Michigan. It could have been Kentucky. Because I always watch my email when somebody reports a rust epidemic in Kentucky. Well, wait 2 weeks. It's going to catch the next tornado or the next storm system, and we're going to see it in 2 weeks, usually. So we'll have to wait and see on some of those. But we know what to look for, though, actually. And so scouting your wheat in the fall is still a really good idea so you could anticipate some of those things. If you saw stripe rust, God forbid you saw stripe rust out there, you might look into what it would cost to apply T2 fungicide to keep that flag leaf clean. So you can factor some of that in the decisions, but we'll wait and see. Good. All right. Well, I appreciate the discussion. So I'll try to get us back. That's good. I appreciate that discussion. So some of the work that we do, we're tied to other researchers, and so I talk a lot about traits in wheat and traits that we can improve to improve profitability. And so we look at architecture, canopy architecture, and so you might think that MCIA warfare, you might think you just need a little bit more nitrogen. You don't have enough biomass on that thing, but there are varieties that stand up straight. It's a tiller angle. It's a function of plant tillers, right? They're more upright tiller angle, And so what that allows, we've found it's not really a yield detriment, and we don't see a lot of them because for various reasons. But this is a trait that we can use. I'll give you the take-home message right off the bat. This is what we're seeing is more space here, in contrast to some of these other lines where they fill out. The tillers are more lateral, and so there's more. They fill those rows, right? A lot of folks are running 7-inch spacing. You can imagine that varieties that have more space there would allow more plants, a higher population, if you could bring those together, right? If you had an extra toolbar on a 15-inch rig, and it takes multiple toolbars. There's some ways to make that work, but there's a lot of, what I'm getting at is all the potential for using the canopy architecture, for which there's a very strong genetic base. The heritability on this, meaning how much of that is genetics, how much of it is the environment, it's almost all genetics. I haven't been able to find what chromosome the genes are on, but we're working on that. So you have these very full canopied varieties, but there is an extent to how much biomass is beneficial, because these leaves are effectively throwing shade on their neighbors. This variety, MCIA Wharf, those leaves, they're working together. They're not throwing shade on their neighbor, and they're able then to use light more efficiently. So this has been a very, very fun story that's developed. I've been evaluating this trait since 2018, and I'm going to connect this to a couple different things, to management decisions, but also I think these differences in canopy architecture are responsible for the variability in how varieties respond to management, i.e., varieties with this more upright plant architecture are able to respond better to nitrogen and fungicide inputs. So if we now have an answer to the question, which varieties should we invest more in terms of inputs? These more upright types, because we found they're more able to use light more effectively, they're able to convert all of those inputs, additional nitrogen and fungicide, into actual grain yield. So there's some work. We've taken different avenues here, and Meninder's been working on the function of planting date. And so these high biomass types with thick closed canopies, they're better for later planting, right? And so there's also the row spacing element that I discussed. And so I've been exploring the high management part of it, and then we can incorporate this into variety development and target traits to specific management schemes, where we're able to then more it's about efficiency and better use of resources where you can invest more in these specific varieties. So it's about light. And so we've got some changes here. So I want to talk about that rating scale first. So this would be what we would refer to as a 5. On the next few slides, we've got a rating scale. Basically, how closed or open is that canopy? And so those more closed canopies, like the Hilliard types or 513, those would be like a 1 on that scale. And these more open varieties, where you can actually see the bottom of the rows, in between the rows, that'd be like a 5. And so there's some major differences. So LAI is a leaf area index. And so all of these 3 different measurements are how much light is getting through the canopy. And so we can see that less light is getting through the canopy in these 1s and 3s. So these are canopies that are fuller, where those leaves are shading each other a little bit more, i.e. blocking out more light. And these more upright canopies are allowing more light in. So we know it has to do with how much light is getting to those plants. And so we have a great photosynthesis research group at MSU. There's a Department of Energy group there that I'm starting to get some folks interested in this. So what really one of the take-home messages is these varieties are better able to convert light into grain yield, to take light and all of those agronomic inputs and convert that into grain yield. And so how that relates to profitability too. So there's a cost associated with adding additional nitrogen. So we've got 90 pounds of nitrogen in just herbicide for our conventional management practices. Versus the intensive management, we're going up to, we're adding 30 pounds, so it's 100 pounds of N. We're adding 2 fungicides. There's a T2, keeping the flag leaf clean and keeping the head clean from Fusarium. And we're adding some sulfur as well. And so this is overall grain yield. These are data from 2021. This was at the Hawk Seed Farm up in Rosebush. And so you could see that we had very high yield potential that year. So in years where there's very high yield potential, i.e. it's cool night temperatures, abundant rainfall, and opportunities to apply those management practices. When given those opportunities, these more upright canopies, the 5s here, have a yield advantage. Now, it might be 5 bushels for some varieties, it might be 3 bushels for others, but 3 bushels, an extra 3 bushels at $8 wheat translates to $3.6 million. Right? So even a little bit of gain goes a long way across a lot of acres. Right? So there's a clear advantage to those. So what this tells us is that there are certain traits in wheat that will allow it to respond better, to get more grain yield for that investment. And we see applying those additional management inputs is going to close that canopy up. Plants are going to put on a little bit more biomass. The rows are going to close a little bit more. And they're going to look at filling out those rows and putting on greater yield. So, right, it's reducing that canopy score. So that canopy is going to fill out. And what we see, so when that canopy starts to fill out, the 5s kind of go away. We don't see those anymore. All we see are they get to the 4. It's a rating scale. And so you can see that these on the lower end of the scale here are responding kind of across the board. But really what the take home is, those varieties that have this more upright canopy architecture that allows more light in have a greater response to management, right? So it's of all those 115 varieties that we're testing, those 20 individuals that have the most upright canopy that's letting more light in, they have a higher response to management, right? Greater profitability from all the way from 0 up to, there's a huge difference in a 5 bushel gain or a 15 bushel gain from a variety. That's a huge difference in profitability. And so if we can target those varieties with specific canopy architectures that are going to respond to those management inputs, that's going to result in greater profitability. So kind of the take home. And this also shows us that those that are putting on more biomass, those ones, the thicker canopies, the more closed canopies, those are going to be more well adapted to sandier soils, less productive soils, less productive fields. If you have a proportion of your operation that you know based on decades of farming that is less productive, you can take these types here you know that you're not going to be spending that much money on that. That ground isn't going to return as much of an investment, so you don't have to invest as much in it. You could use lower nitrogen rates, but then you would have the knowledge to plant a specific variety on that ground. So it allows for precision planting of these varieties, where you could put these probably at a field scale. But if it's another reason to split management, to plant multiple varieties on your farm, because you can cover the more marginal ground with those varieties that don't need the additional inputs, and capitalize on the profitability of the ground that has the CEC to hold the nitrogen that those plants are actually going to use to turn into grain yield. So, all right. So I've got a bunch of science lined up here. I wanted to just check in on how much time we've got. About 7 minutes or so. Okay. So I'm just going to pause and see if we got any questions on some of the work that we're doing on the crop canopy, trying to optimize the crop canopy for production. Yeah. That's right. Potentially. That's a great point, and that's a mechanism of resistance. So the question that was asked was, do those more upright varieties with more space between the canopies have a lower vulnerability to disease, right? Because there's more airflow, there's more circulation through there. That's not something that we've evaluated yet, but I'm going to include that in the USDA grant that we're writing. Actually, that's a really good idea. Sir, yes?
You said the higher management level or whatever results in more biomass?
Yes, we think it's related to biomass.
Is that in straw then?
That's right. The overall straw. So when you look at those plots and you see that they're just more fuller, right? It's like looking at a soybean field after the leaves have dropped. You can actually see the yield. And so when you see the yield in wheat, it's not necessarily in the spikes per se, but it's one of those related traits is biomass. And so that's more straw production. Definitely, if you have higher. So that's another good point. So you could get that more of that biomass if straw was part of your profitability program. You can target that in one of these more fuller canopied varieties. But yeah, that's what we would look at. And so that's where you see in those lower input conditions or more stressful environments, it's biomass that gives that variety an edge, versus some of those more upright canopies might not. They might be more stressed. It's a double-edged sword, right? Having more space and more air flow through that canopy, it might not be cooling as well, right? Under some heat stress types of conditions, those more closed canopies are going to be able to cool themselves. They have more cooling pads, right? If it's from a greenhouse perspective, they have more evaporative cooling capacity. But I really see that extra biomass being a benefit under more low input. And then the upright canopies, then they do fill out. They will fill in. And so you'll have something that you would call it a 5 initially, right? Or under 90 pounds of N, you're going to call it a 5. But when you start pushing the needle on it, it's going to end up closing the canopy more. It's going to be more in that 3.5 to 4 range. So. We do that. We do that in our program. Some folks go out, put it all out there at once, granular. We use a split. It's granular urea. Soon as we can get it out there early, not too early though. So we're out there in around April. But we farm in 8 different counties across the state of Michigan. So we kind of have to do everything all at once. But then we split. We come back with 28%. So that extra 30 pounds of N, that's going to be 28% that we stream onto these plots. So that's a factor in how many times you have to drive over those plots. So they're, So that's the way we work that. Good question. So the point was, do we have increased weed pressure in the upright types? I'm going to say yeah. It's something to consider. So if we struggle with annual bluegrass in our nurseries, that's a big one, and so and it's hard. You can't really predict what the temperature is going to be in the spring. So this is just talking from our program. It was so cold last year that we had to wait until Feeks 9. We had to use buck trill to try to control some things because it was too cold for our go-tos to actually work when we needed to spray them. And so So if you have fields that you know where you have specific weed problems, you could potentially target a canopy that will close faster, or for organic production as well. That's an organic trait, having those more lateral tillers. So even at earlier growth stages, those ones, they're going to be more lateral. That's their growth habit early on, is laterally instead of straight up. They're growing outward and covering the inner row space, which can help control weeds. Very good discussion. Wow. Any other comments? Questions? Yes. Oh, okay. Yes, sir. We haven't yet. I think that there is value in them. If your yield goals suggest that you should be using those, they work. They do work. And there's some interesting work, some exciting work. We use them in the greenhouse, actually, in production to keep our plants real short. But we're working with CCC, and I'm not up to date on the regulatory elements there, but I know it's effective. And there are now the trade name of the other product escapes me. But what I want to comment on is that there is some genetic variability in how they respond to those PGRs. And so that's another, we don't know the answers to that yet, but as we get closer to needing those answers for post-regulation, then we can get those answers too. But they're effective, but there's some genetic variability, definitely. Yeah, and then over there, yes.
In the upright varieties, is it better for airflow to have them in row seeding versus broadcast?
Right. So this would all be based on row seeding. That's right. So this is all on with a 7.5-inch drill. Now, Maninder Singh, you may be familiar with Maninder's work. And this was some work done by actually Calvin Canfield here, where they looked at these more lateral types are better for wider rows. 15. Not saying you should, but they work better under the 15-inch spacing. You certainly wouldn't want to put one of these upright types on 15s, but they would work really well on 5s or 3.5s if we could swing that. Yeah, there was a question over here. Yes, thank you. Outstanding. Outstanding. Thank you for that. Great. Okay. Well, I think that's good. I really appreciate your time. I just want. Can I ask for just like an 8 count, just 8 seconds?
Yeah,
okay? I want to just take 8 minutes. Not 8 minutes. Just an 8 count for MSU. Just. Thank you very much. I teach this semester, so I sent my kids to visit the cows at the dairy today. I made an appointment for them. We're not doing genetics this week. We'll get back to it on Friday. So thank you, everyone. Great to be here with you.
So Eric is the scientist behind all the wheat breeding, and he is super valuable to our program here in Michigan.